we have Dean Tribble on the show right now, the most famous mustache in the interchain, who will teach you everything you have to know about how to code smart contracts in JavaScript. Welcome to the stage, Dean.
Somewhere here I have a monitor. Hello, folks. So I'm going to follow that up with another question. Who here, we have an interesting mixed audience of people that are new to blockchain or new to Cosmos, and folks that are crypto OGs, Cosmos OGs, or whatever. So who here has been working in Cosmos infrastructure for, let's say, a year or more? And I know there's a bunch, so I'd better see some hands. Right? Come on, I can see a few over there. All right, look over there, everyone who's new. Look at people who hands up. Those are the people to go and ask questions of if you have, technical questions for deploying your own next chain. So I have one last question. Who here has used a smart contract in the last day? Yeah, that's a surprising number of people. I bet the number is actually bigger than you think, though. So I worked on the first production smart contract back in 1989. And this is before blockchain. It's 5 years before Vitalik was born. And the basic idea, the fundamental idea of what a smart contract is not about blockchain. It's not software that's running on Ethereum, which was one crazy definition that I heard. It's software that is enforcing the terms of a contract-like arrangement between third parties, right? So that means that Uber, Lyft, Airbnb, eBay, PayPal, all of those are smart contract businesses that have nothing to do with blockchain. Now, they all have a trusted intermediary that you are relying on to not slip illegal trades in like Enron did, or not pick the best places for vacation and not share it with the rest of the crowd, or whatever it is that some of these companies might legitimately be able to do. But that fundamental use and that fundamental concept of software that is enabling strangers to cooperate in a structured fashion was a hugely enabling thing that helped the growth of the internet. So smart contracts were a $1 trillion business long before blockchain was around. So what does blockchain bring to the table, right? So the gold standard for blockchain is multiple independent computers run by different organizations that are not accountable to each other in different jurisdictions, so that there isn't one government that can come in and say, you need to put a back door in this. All coming to consensus, right? Voting, or whatever your consensus mechanism is, about data. Dean has $100 in his account, or Dean put a bid in on an auction. Order of events. Dean put a bid in on an auction and then withdrew his bid, but the auction was closing. Which one happened first, right? And it can only be one, because either I got my $100 back or I won the auction, right? And so something has to choose, and when you've got several hundred machines in different jurisdictions and in different administrative domains, there isn't any one place to stand that makes them all do the same thing, unless you have some of the kind of advanced technology that people have been building in the blockchain industry in order to have these machines come to consensus about that, even when under attack, even when they've got people that are trying to make them do something preferential because, by gosh, Dean wants out of that auction. Right? And, I just hit the wrong button. There we go. And finally, they're coming to consensus about the results of the computation. Not only did Dean win the auction, but here's the prize he got behind door number one. And so the thing that blockchain brings is high integrity of execution. Right? It's that now I no longer need that trusted intermediary, the StubHub in the middle, the eBay in the middle. I can rely on the software directly. And that means I can do more smart contract businesses, which means I can enable more cooperation between strangers, and I can do more kinds of business that I could not have relied on that trustworthy, that trusted intermediary in the middle that I may or may not actually trust. And so that's what blockchain brings. And that's sort of a level set for people that are both coming into the industry, but also people who've been here for a long time working on core bits of technology, but really didn't step back and think about, why is this novel? Why is this interesting? And we've been pursuing this dream, myself, several of my co-founders at Agoric, of enabling more distributed cooperation, personally, in order to enable a more cooperative world, but fundamentally, this is technology to enable more strangers to cooperate for more purposes, for more business, for more social activity, whatever it is. And that's what the technology that we've been building is about. So what's Agoric building? So first off, we were founded in 2018, but several of us had worked together before. As I said, I worked on production smart contracts. Our team has worked on bringing disruptive technologies to markets in everything from standards organizations to startup companies and Fortune 500 companies. And we're building a layer 1 sovereign, independent zone using Cosmos SDK, just like each and every one of you probably ought to do at some point in the next week or so, right? And so this is the Agoric chain. What's unique about it is it enables smart contracts, that is the goal, that is the purpose that we set out to do this, to be accessible to the 10 million programmers out there that already know how to program JavaScript. Now, I'll talk a lot about, it's not just JavaScript, it's hardened JavaScript. We've been in the standards community for JavaScript, the standards committee for JavaScript, rather, for the last 15 years, and many of the elements in JavaScript that people have come to know and love, know and loathe, know and use on a day-to-day basis, whether they like them or not. Promises. Myself and my co-founder invented in '88, and it's propagated all the way into JavaScript and Rust. Proxies, strict mode, several of the things that make it much safer, such that JavaScript at this point controls literally trillions of dollars every day in things like the Bloomberg terminals and tradings engines and all that sort of stuff. And so we've built technology to enable running arbitrarily untrusted code in compartments in a safe fashion, but it still is just normal JavaScript. And so that will enable us to reach out and meet developers where they're at so they can build smart contracts in JavaScript using the tools they're familiar with, the language they're familiar with, the most popular development environments on the planet, practices and approaches, and in particular, the programming paradigms that they have used very successfully to enable millions of programmers to build interesting applications. So, the programming paradigm of independent components built by third parties that you can put together with a framework to rapidly produce a new application. So this is the React-like model that is the sort of best practices for modern rapid development. Right? And I'll talk a little bit more about that. And go into that in quite a bit of detail, because that's a really important element to how it is that we enable people to build smart contracts on our system. So before React, before Vue, before Angular, experts could build interesting applications in JavaScript, in browsers. There were banking applications, there were travel applications, there were all these things, but it took experts. Now, there were a lot more experts than you're going to see able to build Solidity applications now or 5 years from now, but still relatively few. Then out comes React. And that was a framework that absorbed much of the effort to, the zip code changed, that means the tax computation changed, that means I need to change what displays on the screen, right? And getting all that right is really hard and really finicky, and it takes an expert and all that sort of stuff. It absorbed a bunch of that. It made that easy, and it made a framework in which people could build components. I could build a slideshow application and give it to an artist, and he could put it together with Stripe and build a website that would sell his art, even though he couldn't write a slideshow application and didn't know how to drive a credit card engine, right? So he could take these components without being expert, safely plug them together inside of a framework that protected him from missteps and enabled, it had affordances for the things that he needed. Rapid rendering on multiple platforms, good handling of mouse clicks, internationalization, responsiveness, all these things, mobile first, all these kinds of things, such that not very long after React came out, beginning programmers could do a better, more responsive, faster, flashier, sexier application than experts could the year before. And that's because it was a framework that provided the guidance and affordances to solve the kind of problems that the developer needed to solve for his or her application. Right? So we do the same kind of thing, but where the affordances are not mouse clicks and rendering, the affordances are pricing and trading and confirming that you're getting the escrowed good that you want, right? It's the affordances of building smart contracts. And that's what leads to components that you can rapidly put together into new applications, right? And you can have components that have authority that you don't have, right? You know, in React, I can have components that are able to go into the DOM and do crazy stuff that would be unsafe to let normal programmers do, but I can provide you one so it can do beautiful animations and, you know, nice rapid rendering that experts could maybe get right occasionally, but now I can make it available easily to new developers, you know, in their first couple of months, giving them authority, giving them the power to do stuff that they don't have the authority to do directly. Well, we need the same thing in blockchain, right? I need to have components that can do escrow and exchange that I'm not in a position to wire up, but I can use for building a business out of. Okay, so what are some of these components like? We refer to these as DeFi Legos, right? That's sort of a common lingo for this. But it turns out just that notion of pluggable components, you know, Legos that you can put together is a really powerful component notion. So fungible tokens, right? Easy to do. In JavaScript is a one-line example. Non-fungible tokens. Turns out in our framework, it's the same. I just want a new kind of token, and it'll have the following structure. Let me go mint them, right? Automated market makers, the vault for enter, not run. I apologize, I didn't fix this slide. You know, pluggable governance components. I want a simple majority connected to a veto where, you know, after 2 weeks, then their thing will automatically be implemented in the system by this JavaScript code, right? Pluggable components that I don't have to implement the voting mechanism. I can just pick one up and use it. And which means I don't have to security audit that because that was already done. I don't have to get insurance for it because someone's already vetted it and you can underwrite insurance. All these things, these benefits you get from having components you can reuse is a critical element that enables the rapid growth of a larger ecosystem by being able to leverage the components that other people built. Okay, so we also then do components for a larger economy. So on the right-hand side, we have liquidation, right? Fundamental to any large-scale DeFi is I've got a loan, it's got collateral. That works because I can liquidate it. Turns out, liquidation is critical, and it's hard. It's hard to get right. And if you're just building a new thing that your competitive advantage, your comparative advantage is not doing more special liquidation, but rather you're selling, you know, options instead of perps or whatever it is, you could reuse liquidation components that have already been battle tested in other systems if they're liquidating the way you want it. So having liquidation, you know, this fundamental required thing for DeFi, be something that you can just lift and plug in a way that composes well, very, very powerful. Similar oracles, right? Lots and lots of applications, lots and lots of user applications need oracles. In JavaScript, that looks like, you know, notify me, call this JavaScript function when the price crosses 50. And my JavaScript function can do anything I want, including, you know, take a liquidity position and sell it. Or, you know, or oh, it crossed 50, let's go buy this new asset, or whatever it is, right? That kind of thing, where you've got components, ends up looking like very small JavaScript programs you could explain to someone that's only been programming for 3 months. Try that with Solidity, right? So, you know, the kind of thing that ends up looking like is, oh, well, bring it to the next one here, right? Well, you can only sort of see it. There's lots of examples in our code, but just like with React, a smart contract is a module. It exports a single function, in this case called start. And that, you know, in this case here, it creates a new mint for non-fungible token that, you know, mint equals a weight, blah, blah, blah. Down below, it does I think it's down at the bottom, it mint gains. That's the operation that will mint a new token. That will mint a new token using that brand new NFT that I just instantiated, that I just created a new issue for in, you know, one line of code up here in my smart contract. So you can end up building smart contracts that are just, you know, look like a component that millions of programmers are familiar with. Okay, so we have. So people using this, Byte Pitches here, they'll be doing a workshop and talking later where they're using these same components to not just, you know, to not solve our problems, but to build a lending protocol, like some of the lending protocols you see on other platforms, all in JavaScript, all running on the Agoric platform. Right? And so they'll have a workshop about how that all works and how they're building it and what they learned using our initial APIs and what feedback they have for us that we'll respond to, all those kinds of things. Similarly, most of the NFTs are currently in their infancy, really, where you've got sort of signed autograph things. But the future of that is really about engagement, right? It's about tribes. It's about being a member of a group, being a member of a fan club, being a member of an airline mileage plan, right? Humans organize in groups where they now want to combine their membership with groups with financial activity extended by third parties. As soon as you add financial activity extended by third parties, man, blockchains and their high integrity and smart contracts and that enabling of money combined with cooperation enforced between strangers, it's just hugely powerful and enhancing to all of that kind of human activity. Most of the people doing that stuff, right? Band sites, sports sites, those are all JavaScript programmers, right? So enabling them to be able to extend the NFT world, enabling you to be able to extend the cooperation that is involved in all of those kinds of engagement NFTs, hugely valuable to do that in JavaScript. So we have, in JavaScript, reusable components of NFT minting contracts, NFT drop management to be able to, sell batches or sell, rate frequency of items. All of the primary listings, secondary abstractions, like several of the DeFi components, the auction components for DeFi, in our system, they work just as easily. The same JavaScript auction, the same escrow agent. It works equivalently across fungible tokens or non-fungible tokens, or, well, as we now support semi-fungible tokens that you can talk to me about in the break, right? So all of these things let you build interesting applications where you have demo applications where we did a baseball card trading app, and then someone outside, not at Agoric, took it and added the secondary sales and the ability for someone to manage their collection, not because I collect baseball cards, but because an astonishing number of these NFT applications need all the same kind of service, but again, with pluggable components where someone who wants to deploy a new thing can rearrange what it looks like, but it's the same underlying functionality and the same extensible component that you can now add a little bit of behavior to and roll out a new business, right? So this whole component model will let a lot of people do similar but just slightly different things tuned to their particular group and use case. Okay, so behind that, we then have a group here that will also be talking, Crya, that they're building not just NFTs, right? But it's a NFT construction project where the character, which you can see, there's a face here, the hair, the mask, all these things. That's a character that might be in a game where each of the components there is itself an NFT, right? So it's not, here's 10,000 things, you can now buy them. No, this is about, here's a character, you can buy the mask, you can buy that headpiece, you can put them together, cons that up into your character, and then using exactly the same DeFi components, you could sell that character. Or you could take off the mask and sell it independently, or trade it for some other thing that you needed, and then put that on your character, and so forth. And they've already got folks that are, the artists that are producing this, interesting, new, rich way of combining NFTs, and it's structured to be able to form new kinds of games based on this stuff, right? And, being an NFT doesn't necessarily mean this is about, let's arrange to sell this for thousands of dollars. It means new kinds of cooperations between people based on art assets that they want to participate with. And whether that's worth a lot of money or just worth your weekend time to be able to enjoy this stuff, those, to me, are both incredibly valuable ways that this new technology can enable humans to cooperate. Okay, so people ask us why JavaScript. And there's no question the first answer is 10 million developers, right? Actually 13.9 as of last count, million developers, where with a simple model, with their, the number one language, it's the number one language on the planet, it's got the number one development environment, it's got all the development practices, enabling people to program the stuff we want to leverage and add components that we can all use, that's a win. All you developers out there, there's a really good chance you've done JavaScript development, and there's a really good chance that you're going to have to do that even if what you're doing is talking to stuff in other languages. Having the same environment, the same tool set across all of your application can be really empowering. Right? There will be a community, there already is a community that's growing, that's building these components, and that's pretty critical. But it's actually more than just the community. It turns out that JavaScript, and people, it's like, what the hell are you doing? Oh my God, JavaScript security, right? JavaScript is more securable than pretty much every other language that's generally available out there. It's like, oh my God, Rust is supposed to be wonderful and secure, right? And I love Rust. I love WASM. Agoric folks helped with the launch of WASM when it first started up, and helped with making sure it had an architecture that was composable in the blockchain space. So we are big fans. But when you compile code, when you put things together in normal compiled languages, so we're talking Java, C#, Rust, and Go, any of those things, you're taking libraries, and in this compiled thing, they're approximately assembly language. They can run with the arbitrary authority of the application that you're running, right? So you can't have a component that is more privileged than you, that is handed to you that you can use, and have it run in the same compiled WASM compartment, right? Because if someone can inject any kind of compiled WASM that you didn't inspect the source code of, it could be assembly language that can now violate the encapsulation boundaries that you, the programmer, were assuming, right? And this is a standard software, library exposure that you get in large-scale systems. But it turns out that most applications, right, 97% of the code comes from libraries. And that means 97% of your code, this is a GitHub statistic, is coming from code that, yeah, maybe you've looked at, but in an environment where it could do anything at once, that's kind of a dangerous exposure. And we have seen losses of hundreds of millions of dollars due to libraries that, they used more authority than you expected, right? Or they were executing code at the level of EVM or WASM or whatever the compiled execution instruction set was, and it was able to do things that you could not express in Solidity or Rust or Go or whatever programming language you were using. So there's non-trivial security issues that, as an accident of history, which I'll happy to talk about later, are actually addressed in JavaScript. So in JavaScript, all authority of the program comes from objects that are handed into you from the global environment, right? In the browser, if you can't get at document, then you can't do anything to the DOM. Done, right? It's just not possible. There's also some malleability where you can change what array iteration does and stuff like that. Hardened JavaScript locks all that down and uses this fundamental architecture of JavaScript to use, it turns out, secure OS practices from the strongest and most secure OS architectures on the planet to enable having compartments where I can have an object that has the authority to take the client's money and spend it anywhere we want. But what I provide to the contract is just, I've escrowed, this low-level secure component called Zoe, this low-level element of the framework, has locked up the offered assets. Someone says, I will give you Atom if you give me Osmo, right? Well, it's locked up the Atom. It has not made it available to the general smart contract code. And now the general smart contract code knows there's Atom to be had there if only you could provide the Osmo. And now the only way it can get the Atom out is if it provides the asset that the client asked for, right? This is what we call offer safety, that the client didn't say, here's some Atom, I hope you do something good, right? Send money to a random number and hope something good happens. No. It said, I will give you Atom if you give me Osmo, right? And the Atom goes into escrow, the JavaScript code runs using objects that it can say, okay, here's some Osmo, give me my Atom. And the underlying thing says, yep, that's the Osmo I was looking for, here's your Atom. We've now done an exchange, but no bug in the contract, no malicious behavior, no rug pull in the contract can cause that Atom to be given to the contract unless it provides the Osmo, right? And so there's literally billions of dollars lost on Ethereum of contracts that they take the asset in, then they screw up, and the user doesn't get their money back, right? So having a framework where I can have strongly privileged components running in the same environment in a very lightweight fashion with the user-defined, arbitrarily untrustworthy code, and knowing as a client that I can provide assets and either I get what I want or I get my money back, no matter what the contract code is, man, that is just a huge reduction in the overall security risk of each individual contract, security risk to clients, security risk to developers, security risk to the overall system, right? It enables a new level of writing smart contracts. So that's why JavaScript is we can actually make an environment that will actually be safer for building all these smart contracts than you can do in any other platform that we've seen. Okay, so I only have a couple more minutes. I will race through some of this. So we have a layered system. It is a big project. We're getting there. We're almost done, but it's a big project. We use Cosmos Tendermint underneath. Thank you all for having built all that stuff. I mean, yes, we support it, but man, the experts are not at Agoric. The experts are out there in the community, and it's awesome stuff. And we use build as our staking token. We have the Agoric VM, which is standards-compliant JavaScript with running hardened JavaScript so that it is in this lockdown environment that lets us have, long-lived, persistent processes that will load back up and continue running if the machine goes down, and all these kinds of lovely technology things that you can use in Web 2 as well as Web 3 stuff. With the smart contract framework, this React equivalent but for doing smart contracts, called Zoe, that provides that thing I was saying of offer safety, where you can't get my atom unless you can't get what I give you unless you give me what I want, right? And then on top of that, we use that very framework to build an ecosystem, to build an economy, to build a stable token that I'll talk a little bit more about in a moment. And then on top of that, you build your user-defined contract. So that's the layers of the system. So let me do 55 seconds, we'll see. So we have our staking environment underneath. Above that, we have the smart contract economy where, JavaScript, tools, components, all those things provide the build fast side of that mantra that, at the very first slide, I said build fast, earn fast. That provides the build fast slide. But the goal is safe, rapid construction of smart contracts that run in a stable economy. That's what we're providing. And for an economy, to my mind, to economists' mind, requires a stable token to provide the grease for exchange, right? So that you can see that the price of an asset is the same today as it is tomorrow. So that the cost of execution, right, is not twice as much tomorrow because the token went up. It's only twice as much tomorrow if you actually see the price change, right? So having, moving from the barter economy of existing things like ETH and so forth to paying a stable token so that you can compare prices on a day-to-day basis and you can compare prices on-chain with prices off-chain, that really simplifies having exchanges and having economy. So we build that into our system. There'll be a talk later today about the interprotocol, which is the stable token that we're building for our system that, oh, by the way, is useful for a lot of other potential systems. But you as a developer will just encounter IST, that token that lets you just price things in a general fashion and pay for network services. There's several elements of that inner protocol that we'll talk about later, but like the AMM, like the stable token, like the trading elements. But that's in an environment where lots and lots of smart contracts, including the ones you build, can deploy. And so this is the ecosystem where you build smart contract components, you deploy them there, and they can participate in this much larger economy that allows smooth business interoperation between all these contracts. Okay, so we're almost there. We've been working on this for a long time. We're in the phase where we just completed a security audit of our underlying kernel. We are now we'll be heading shortly into a third-party security audit of the larger scale smart contract stable token ecosystem. And so we're doing third-party security audits of that, as well as big economic stress tests to make sure that, to the extent that you can test not in production, we've got an infrastructure that allows us to roll out, 80 machines that are all beating on, on 120 validators to do, to try out various liquidation scenarios and so forth. So we'll be doing economic stress tests with economists trying various different attack models and so forth in order to do the best we can to simulate that level of assurance at the economic level, not just at the transactional and consensus level. And then we will be coming up in July with release candidate 0 that will then go through validation, integrate and with IBC to connect into everyone else's testnets, and rolling out the overall first launch of the stable token and economy late summer. So There's a bunch of events. I mentioned several of the people that are building on Agoric. They will be having workshops talking about how they're building, what they've learned, why it's good as a JavaScript developer. We'll be talking about Inter later on, and I will be available to talk about any layer of this technology elsewhere in the conference and at a couple of office-hour sessions. We have a room over there which has graphics all over it from somewhere here is Lucian from Designatives that did a beautiful job on the graphics. And so please come by and visit. We really look forward to talking to you. And I know I'm a little bit over time, but it may be that we can take some questions. See if he lets me.
Yeah, thank you, Dean. Yeah, one round of applause, please. Yeah, we can actually take one question, and I think that's a good one because you had a panel about it just in the morning. So do you think that Agoric will benefit from the Terra drama as more developers could go ahead and build on Agoric instead? So for us, the hardest thing to scale is the developer base. And our focus is getting out there to the JavaScript developer base, which is, there's a lot of really good developers on Terra. There's a lot of great developers that have now expertise that is hugely relevant to the overall Cosmos ecosystem. But it's still, hundreds, maybe thousands, as opposed to millions. So we could benefit in the short term. I'm a lot more interested in them applying as much leverage as they can to do COSM WASM things, coming over and helping us and integrating with us so that we're talking to Juno. But our focus is people that are going to build in JavaScript, and we have a unique position to be able to bring in to Web3 the developers that aren't here yet. And so yes, we'll benefit a little bit, but mostly we're focused outward. Yeah, very excited for that, and also keen to see this network effect on Agoric. Dean Tribble.
Thank you. Thank you for having me.
Yeah.